Good morning. This is Professor Ma, and today we talk about the algebra for difference quotients. Okay. Let's review the notation for functions. Okay. Actually, this is the key part of this section is to interpret the symbols, the function notations. Okay. So suppose I have a function f of x is 2x, then if I plug in the number 3, x is 3, then 2 times 3, the answer is 6. And if I say what's f of 3 plus 1, so the 3 plus 1 actually means that you're supposed to add a 3 and a 1 first, which is 4. Then put in the formula, then we get 8. And notice this is different from these. Okay, if the plus one is outside, then means that you have to find out what F3 is first, then add 1 to the result. In this case, it will be 2 times 3, which is 6, then add 1 afterwards, which come out to be 7. So notice this is different from the one before, adding the 1 to 3 before you put in the formula versus adding the 1 after you put the 3 into the formula. Okay, so the same difference you have to be able to identify if there are symbols. What's f of y plus 1 means you plug in the y to the formula 2x, which is 2y, then add a 1 afterwards. Versus what? Add a 1 to the y, plugging into the formula. Then you will have twice of y plus 1, which is 2y plus 2. Okay. And same thing for f of x plus some number h. H is just some other quantity. Okay, and so that means take the number 2x, then add h afterwards. Versus if I add h to the input first, x. Okay, and then I will get twice of x plus h. Then the answer will be 2x plus 2h. Here's an example for second degree formulas. Okay, so suppose I have a second degree formula x squared minus x plus 1. Then these expressions right here says take the formula, then add the amount h to the formula. So the answer is okay, it's x squared minus x plus 1. Add the h to that. Versus, okay, add the h to the x, then take the entire x plus h as the input into the formula. Then you will have to square x plus h minus the x plus h. And then you have to expand it, and this is what you will get, which is a lot more complicated, a lot lengthier than the one on top. Okay, if you put the h with the x first. Okay, so make sure you know the difference of these two. Okay, now let's go to difference quotients. The purpose of this section basically translate the formula for slope into the notation of function f of x in general. Okay, so the first thing to realize is when we talk about a point, okay, on a generic graph, here's a generic graph. We say, well, y equal to f of x, some graph, okay? And I'm at a generic point x and some Joe below x, and I say, well, what's the point corresponds to the x on the graph? That point will be x, whatever x is, and the y, of course, the y, of course, is the y component is what you plug in x is f of x. So this is the generic pictures of generic functions of a point, generic Joe below point x and its point on that graph. Okay. So this association between symbols and the pictures is extremely important. Okay, where the location is and what it is notated, the coordinate of the point. And in particular, f of x is the y component. That will be the height of the point. Okay. And if I move it over, then correspondingly, I can write on the coordinate for the point x plus h. You say, what's x plus h? Oh, h is just some small amount that you moved over, okay? So from here to here, if you want to say what's h, so basically the distance from here to here, this is h, okay? It could be 1, 2, 3, 4, just some neighboring distance from x to the point x plus h. And then the purpose of this section is, okay, once I have this set up, I can connect a line from here to here. Then I can talk about the slope of this line. Okay. You say, why would you want to connect 2 points on a graph and talk about slope? You will see that later on, that become a very important formula. That's a difference quotients in the title. Okay. So here we go. Here's a picture. So I connect a line and I want to calculate the slope. The slope, of course, is change delta y over delta x. Okay. What's delta y again? Delta y is from here to here. If I draw a line, delta y is how high this is. Delta x is how far you go over. Delta x, in fact, is the same number as h. Okay. So if I translate this slope formula using the coordinate x plus h, x, f of x plus h, f of x, all these coordinate quantities, and then the formula becomes this. Okay. This is called the difference quotient formula. Okay, and what are we going to do with this difference quotient formula? We are going to work through 3 types of algebra, okay, with this difference of quotients formulas. And the ultimate final step for all these 3 types of algebra is to manipulate the expression. And so at the end, this h is somehow canceled out by hook or crook. Okay, and here are the 3 versions. This is just an example, a numerical example to demonstrate what the h is doing there. But this is the main things. Okay. Simplify the difference quotient for this formula f of x. Okay, so what we have to do is simplify these expressions. Okay, this is called the difference quotients formula. I'm going to plug in x plus h into f of x and subtract f of x. So this is what it comes out to be. Remember what we talked about f of x plus h is in the beginnings? So this is what f of x plus h is, all these. F of x plus h is all that. And f of x, of course, f of x is just a formula itself, is all that. Okay. And notice I subtract, so I put a bracket. Make sure I protect the subtraction, make that subtraction correct, okay, without possible missteps. Okay, and if you do it correctly, then at the end, h can be always factored out and cancel with h on the bottom. So this is the algebra for 1 type, 2nd degree formula, quadratic formula for the difference quotients, how the algebra work out. The 2nd type is simple fractions. These is the ones that you're going to wind up with complex fractions. So if you have problems with these, go back to the complex fractions sections, I think chapter 8, last sections. Okay. This is complex fraction clearing denominator, the tricks of multiplying by least common multiple, a denominator to clean up all the denominators. And lo and behold, the h will cancel out at the end. Okay. The 3rd type is a square root, a simple square root type. Okay, again, plugging x plus h correctly, I got these subtractions of two square roots. How do I clean these up? I use the conjugates. Okay, so multiply the top and bottom by the conjugates with a plus sign in the middle. Okay, and the trick I'm using here is the formula x minus y times x plus y is x squared minus y squared. Okay, this is the x I'm talking about, this is the y. Okay, so x minus y times x plus y. Okay, and what would happen? Well, what will happen is this. Okay. Oh, by the way, again, don't do anything to the denominator. Okay. And x squared, y squared, if I square and multiply these, I will get a square root square, which is just that, minus the other square root square, which is just this. Okay. And so this is how you clean up a simple square root formula. Multiplying the conjugates, and again, what it comes out with h will becomes it will be only h is left on the top, and then you can cancel with the h on the bottom, and that's the finished product. Okay, and yeah, so that's the algebra you have to do on the difference quotients. Okay, I'll see you Thursday. Thank you. Bye bye.